Hello and welcome to this segment of reInvent 2018 announcements. This is Compute segment. My name is Harsha Nippani. I'm a solutions architect at AWS. The agenda is new EC2 announcements, new EC2 features, AWS Outposts, Firecracker, the new Lightsail features, wrapping up with some of the Lambda announcements. EC2 instances. Amazon EC2 has a broad spectrum of categories in which you have EC2 instances that you could launch, and also with a wide array of capabilities. With the recent additions, we have new options that essentially giving you a breadth of options with compute, including general purpose, burstable, compute intensive EC2 instances, memory intensive, IO intensive, and GPU-based and graphics intensive. In addition to the categories, we have recently announced a choice of processors, including Intel, AMD, and AWS, high memory footprint instances, and also accelerated computing. We will be reviewing some of those announcements in this segment. AWS EC2 platform has broadest choice of processors and architectures. The most popular ones are the Intel Xeon-based processors, especially the Skylake version. We also have, for the accelerated GPU, we have NVIDIA-based TensorFlow Core-based processors. And at reInvent 2018, we have made two additional announcements, AMD EPYC processor and also AWS Graviton processor. Why do we have so many choices? It is essentially to help you, the customer, leverage multiple options and select the right compute for the right application workload. Let's dive into some of these specific announcements. We launched EC2 P3DN instances. These are the P3DN 24XL enables developers to remove data transfer and pre-processing bottlenecks in HPC workloads. It is our most powerful GPU instance yet. It delivers 4 times the network bandwidth as of when compared to P3 16 extra large. The advantage of P3DN is it delivers up to 100 Gbps networking throughput, significantly lowering the time to train machine learning models and run HPC simulations by scaling out your jobs. Some of the important takeaways from P3DN announcements is these are the P3DN family are the most powerful GPU instances available in the cloud. Machine learning models require a large amount of data processing and training in addition to increasing the throughput and passing data between the nodes. So in addition to network throughput of P3DN 24 extra large, you can also speed up your large amounts of training data by connecting to Amazon S3 or shared file systems using Amazon EFS. P3DN 24 extra large can be launched with deep learning AMIs that include support for most popular ML frameworks like TensorFlow, MXNet, PyTorch, and Caffe2, in addition to others via SageMaker. Placement groups and multiple flows required to get the 100 Gbps throughput within the flow. And there is a 5 Gbps limit per flow from S3 to other services. So in summary, P3DN, faster networking up to 100 Gbps, more memory per GPU, 32 GB per GPU, more vCPUs, up to 96 custom Intel Xeon Skylake vCPUs, 1.8 terabytes of local NVMe based SSD storage, and elastic fabric adapter compatible. Next announcement is EC2 C5N. EC2 C5N is our latest, again, it's based on the Intel Xeon processor, the Skylake processor 8000 series. It also delivers up to 100 Gbps networking. This is ideally suited for applications that require higher network bandwidth and network throughput. And also it features 33% higher memory footprint as compared to the earlier C5 versions. Important takeaways from C5N announcement is it unblocks any network-bound workloads. It has a range between 25 Gbps to 100 Gbps, and it offers significantly higher network performance across all instance sizes, ranging from, like I mentioned, say 25 Gbps, where C5N large delivers, and up to 100 Gbps, which is C5N 18 extra large. And in summary, more memory per core, faster networking, full memory bandwidth, and compatible with elastic fabric adapter. Moving on to the next announcement, we announced EC2 A1 instances. This is the first instance powered by AWS Graviton processor. A1 instances deliver significant cost savings to customers with workloads that are ideally suited for scale-out and ARM-based workloads that are supported by the extensive ARM ecosystem. A1 instances are the first EC2 instances powered by AWS Graviton processors that feature 64-bit ARM Neoverse cores and custom silicon designed by AWS. You can deliver up to 45% cost savings by leveraging these for scale-out functions for your workloads. They come in 5 different varieties. They're currently available in US East 1, US East 2, and US West 2, and Europe, Ireland region. And there are 5 variations of A1 instances, delivering up to 10 Gbps networking and EBS optimized burst. And the maximum number of CPUs is the A1 4XL with 16 vCPUs and up to 32 GB memory. In summary, the takeaway for A1 instances is EC2 A1 instances are powered by the new Graviton processor with 64-bit ARM Neoverse, ideally suitable for scale-out functions, scale-out workload for ARM-based workloads. In addition to that, another announcement in the EC2 segment is new AMD instances for cost-optimized compute. AMD, with their EPYC 7000 series processors, are new variations in the EC2 M5, R5, and T3 instances. For customers who are looking for cost-optimized way of delivering compute capacity, by leveraging AMD, you can realize up to 10% of cost savings in compute and memory. Seamless application migration, because these are based on x86 platform, so there is not really much of a change in terms of processor architecture. In the next segment, we'll be talking about EC2 features, the new features that were launched. New EC2 features that was announced is hibernation, EC2 hibernation. You can announce, you can essentially now hibernate your EC2 instances backed by EBS volumes and then resume at a later time. Why is this important for customers? Because it allows customers to hibernate the state of memory of an instance and a disk and bring them back online very quickly. And how is that helpful for customers is if you have application workloads that take a lot of time to warm up by loading applications into memory, this will speed up, this process of hibernation will speed up application uptime. To hibernate an instance, it must first be enabled for hibernation during the launch time. All you have to do is to enable hibernation at launch using the console or the command line. And applications can pick up exactly where they left off instead of rebuilding the memory footprint all over again. That's the biggest takeaway in terms of the value add. Another new feature is Elastic Fabric Adapter. It is basically a new network interface designed with highly throughput and low latency in mind. Elastic Fabric Adapter is a network interface for EC2 instances that enable customers to run HPC applications requiring high levels of inter-instance communication, like computational fluid dynamics, weather modeling, financial modeling, and reservoir simulation at scale on AWS. With EFA, Elastic Fabric Adapter, applications utilizing the message passing interface, the MPI, can now scale to thousands of CPU cores. And today it's available on C5N and P3DN instances. And the key takeaway here is using EFA, it allows you a mechanism to, essentially it provides you an OS bypass and a user space API on which low latency applications can be built. Typically, those are HPC applications. The next announcement is AWS Outposts. AWS Outposts brings native AWS services, infrastructure, and operating models to virtually any data center, co-location space, or on-premises facility for a truly consistent, seamless hybrid cloud. AWS Outposts is designed by AWS and fully managed infrastructure. It can be deployed on-premise, in data center or edge locations, or in a colo facility. The key is you can run key AWS services locally using AWS Outposts. That has been a request from many of our customer base, And the advantage over there is native access to full AWS services via this platform, and one consistent management plane across whether it's on-premises or cloud, and choice of AWS and VMware-based control planes. AWS Outposts come in two variants. One is native AWS, meaning this is deployable in a customer environment on-premises. It has the same APIs and services and features as in the AWS cloud. It supports EC2 and EBS with feature support and requests for RDS and ECS and EKS, EMR, and SageMaker that is in the works and will be delivered in 2019. The second variant of Outposts is VMware Cloud on AWS. So VMware SDDC as a service is built in on AWS Outposts. So VMware APIs and services to leverage and existing skills and automation and governance policies that you have can easily be ported over to the VMC solution on Outposts. And why is this important? It essentially gives you a single consistent operating experience. One management plane delivers high degree of control for IT administrators. And previously, IT administrators had to manage the separate cloud and on-premise environments, which require different tools, different processes, and also duplicating the effort. Whereas with the Outpost announcements, you can essentially use your existing toolkit, your existing skills to leverage both on-prem and cloud-based workloads. The next announcement is Firecracker. What is Firecracker? Firecracker is an open source micro VM-based virtualization technology. It is essentially a virtual machine manager, a VMM, based on Linux KVM, and it provides a RESTful API to create and manage micro VMs. What is the advantage of micro VMs? To give you an example, Lambda and Fargate services of AWS use Firecracker technology. The most important benefits are A, security. From the ground up, micro VMs use KVM-based virtualization, and this is built on the Nitro technology, and speed by design. What I mean by that is it has minimal device and kernel modules, which will help in creating in the creation rates of up to 150 micro VMs per second per host. And also, user code and application is less than 125 milliseconds. So it's a very fast way of spinning user space and also application space micro VMs. And you can scale in the micro VMs in a very effective manner. Each micro VM has less than 5 megabits of memory overhead and built-in rate limiter, which optimizes a shared network and storage resources. As I mentioned, Firecracker technology, here is a network diagram of how it looks like. Essentially, you have the bare metal server, on top of which we have KVM-based, host-based kernel space, and on top of that is your micro VMs, with essentially having a control plane and a data plane. Control plane managed by AWS and data plane managed by customers. The next announcement is new Lightsail features. Lightsail gives you, there are two announcements within Lightsail. One is export to EC2. A snapshot from Lightsail can be exported to EC2 AMI, a convenient path to migrate to AWS. And the second announcement is Lightsail resource tagging. Why is that important? You can essentially label using a key value pair to manage and search and filter resources using Lightsail resource tagging. And that can be used to organize your billing and control access, because now you can leverage tagging, tagging-based resource controls through IAM, or also for chargeback models. It's easy to leverage tagging for chargeback. That wraps up the compute segment. In summary, there are really cool features that we have announced, from a breadth of options for customers in terms of leveraging multiple types of processors, from AMD to AWS Graviton to Intel to GPUs to AWS Outposts to new Lambda features, and essentially giving you a wide variety of choices that are suitable for your workload. If you have any questions, any follow-ups, please reach out to your AWS account team, account managers and solution architects. We'd be happy to assist and respond back to you. Thank you.